Let's solve the inequality that results by having f of x set less than or equal to 5. Okay, so in other words, we have the absolute value of 2x plus 1 is less than or equal to 5. Okay, so before I go any further, I want to pay attention to this symbol here. That is a less than or equal to sign. Okay, so the function is less than or equal to 5. Okay, so whenever you see the word less than, I want you to think of the phrase less than, because this is an and type problem. Okay, and we'll talk about the difference between an and an or problem as they come up. Okay, so put the word and right here, and then I'm going to use our standard set it equal or less than or equal to the positive, and then do something with the negative as well. Okay, so the inside part, 2x plus 1 is going to be less than or equal to 5, and 2x plus 1, this is where I put the negative 5, but when you change the sign from a positive to a negative, you also change the sign of the inequality. Okay, so notice I flipped it around. Now it's a greater than and equal to sign. Greater than or equal to sign. Okay, so whenever you change this to a negative, you also change the sign. You flip them both together. Okay, so those are two inequalities with the word and in between. Okay, that has an impact on my final answer. Okay, so ignoring that for now, let's solve them one at a time. On the left, 2x plus 1 is less than or equal to 5. If I subtract 1 from both sides, I end up with 2x is less than or equal to 5 minus 1 is 4. Divide both sides by 2. X is less than or equal to 2. And, let's solve the right. Subtract 1 from both sides. Negative 5 minus 1 is negative 6. Divide both sides by 2. Negative 3. So x is greater than or equal to negative 3. Okay, so the word and. When you see the word and, I want you to think overlap. Okay, overlap. Well, what does that mean? All right, let's draw a number line to kind of give a visual for what's going on in this problem. Okay, so here's my number line, which spans from negative infinity to positive infinity. And we know we have 2 over here somewhere. We have negative 3 over here somewhere. This does not have to be drawn to scale, obviously. Okay, and so let's take these one at a time. I'm going to color code this a little bit. Let's say that x less than or equal to 2 is blue. So x could equal to, so I'll put a dot there, close circle, or x could be less than 2. Okay, so that blue region represents all the possible values for this left side here, x less than or equal to 2. Okay, now let's use pink for the right side. Okay, x is greater than or equal to negative 3. Okay, that says that x could equal negative 3. Or x could be bigger than negative 3. Okay, and like I said, I want where these overlap. Okay, so where do these overlap? They overlap from negative 3 to 2 and everything in between. Okay, so how would I notate that as my final answer? X is any value between negative 3 and 2, starts at negative 3, stops at 2, including negative 3, so I put a bracket. Okay, ordinarily I put parentheses when dealing with interval notation, but in this case I'm putting a bracket because x could equal negative 3 and our original inequality would be true. Or x could equal 2 and still everything would be okay. And anything in between. So anything in between negative 3 and positive 2, including negative 3 and positive 2.